In this experiment, we're going to be looking at the properties of a gas that we are going to generate through a reaction. So I'm going to take sodium bicarbonate, or also known as sodium hydrogen carbonate. This is baking soda. So those of you who have done the volcano experiment in elementary school, that's what we're going to do here. So the gas that is generated when we mix sodium bicarbonate with an acid is carbon dioxide gas. So I'm going to measure some of the physical properties of this gas. And what I want to do is put it around this candle so that I can measure the flammability of this gas. So I have some sodium bicarbonate and I have a little candle stand just so my candle doesn't fall over. I'm going to add vinegar and I'm going to watch the effects of a flame. So I want to light my candle so that I can tell if carbon dioxide is flammable or not, if it supports combustion. So I have a flame going. I'm now going to add the vinegar carefully around the side so I don't hit the flame. And you can see there, a gas definitely was evolving. We have bubble formation, and the flame went out. I'm going to try to relight that flame to see if carbon dioxide is heavier or lighter than air, and I'll discuss this in a minute. So as soon as I try to put my match inside, it goes out. I'm going to wait a few minutes and see if the same thing happens. So I still am unable to relight even minutes after the reaction has completed. So that suggests to me that carbon dioxide is staying inside the beaker. So we have air that is on top of the beaker. We're comparing whether the carbon dioxide is heavier or lighter than air. If it were lighter, it would escape outside of the beaker, and we would replace carbon dioxide with air, which contains nitrogen, oxygen, and carbon dioxide. Oxygen, we know, supports combustion. So if the carbon dioxide stays in the beaker, if it's heavier than air, that means that we should not be able to relight the candle. So I've seen here, I was unable to relight the candle even minutes after the reaction stopped. So that suggests to me that the carbon dioxide is staying inside of that beaker. It cannot escape because it is heavier than air. The physical properties of carbon dioxide: it was a colorless gas. You could see the bubbles forming, but you couldn't see the gas that was coming out of it. It has no smell, and it does not support combustion, as we saw by the fact that the flame was put out when we added the vinegar. In this experiment, we're going to be looking at the effects of Boyle's law. This is one of the gas laws that relates the pressure and the volume. So we're going to be looking at the volume of the gas inside of the orange balloon. So right now I have my vacuum set up. I have the aspirator hose connected using black vacuum tubing to this secondary containment. That way, if any water gets pulled into the reaction flask, it will go into this containment flask. The containment flask is connected to our larger Erlenmeyer. So if I stopper that, we are going to have a vacuum set up. So when I turn the water on, we're going to observe the volume of that orange balloon. You're going to be looking to see if the volume increases. If it is expanding, it will get bigger, or to see if the volume decreases. What I'm doing is decreasing the pressure. So I am turning on a vacuum aspirator that will lower the pressure. So we're going to observe the volume change at a lower pressure. And I'm going to turn off the vacuum by removing the seal and then turning off the water. So you can see that the original size of the balloon has been regained at the original pressure. In this experiment, we're going to be looking at the effects of Henry's law. So I have a can of seltzer water here. I'm going to open it up, and you'll be able to hear a change in the pressure when I do that. So Henry's law relates the pressure to the solubility of a gas. So what we're going to be observing are bubble formation means a decrease in solubility. So we are going to relate the pressure to the solubility by looking for bubbles. So when I turn on the vacuum aspirator, I'm going to be decreasing the pressure. We want to see what happens to the solubility of the gas. So I'm going to pour a little bit of seltzer water into my vacuum container, and I do have some bubbles forming here, so I'm going to wait a minute to make sure that they have stopped before I put it under vacuum. So I still have some bubbles forming, but we're going to go ahead and turn on the vacuum and see what happens. If we increase the bubble formation, that means we're decreasing solubility. If we decrease bubble formation, we're increasing solubility. So you can see there after I tightened the vacuum, we had a lot more bubble formation. As soon as I released the vacuum pressure, meaning I increased the pressure, you could see that I no longer have bubbles forming. I also have a little bit of fog inside of the container. We're just condensing some of the liquid that was or some of the vapor that was being generated when we were at low pressure.